Working example number 4, evaluate quantities with an exponent of 0. So we're starting with evaluating 3 to the 0. We're actually going to break this down a little bit using a table. Complete the table to find the pattern in the powers of 3. So 3 to the 4th power is equal to 81. If you divide that by 3, 81 divided by 3 is 27. Initially, this may not make sense. Just go with it for the moment. Hopefully, you'll see it by the time we finish as to what it is that we're doing. So that becomes 27, which happens to be 3 to the 3rd's value. Divide that by 3, it's 9. 3 squared is 9. 9 divided by 3 is 3. 3 to the 1 becomes that. 3 divided by 3 is 1. Then 3 to the 0, well, what goes there? So if you watch the pattern, this value divided by 3 is 27, so that goes in the next row down. Divide by 3 again, that 9 goes in the next row down. Divide by 3, that 3 goes into the next row down. Divide by 3 goes in the next row down. So if you follow the pattern, this exponent is decreasing by 1, the value keeps dividing by 3. So that's what this table shows, is that 3 to the 0 must be equal to 1. So you can use division as well to show that 3 to the 0 is equal to 1. You can choose any power of 3, such as 3 to the 4th, and divide it by itself. 3 to the 4th divided by 3 to the 4th. Well, using our laws, we know if we do this with division, then we take the two exponents and we subtract them because it's the common base. So 4 minus 4 gives you 0. But any number divided by itself is going to give you an answer of 1. So if you see that over here, 3 to the 4th is equal to 81. Well, 81 divided by 81 is 1. So 3 to the 0 then is also equal to 1. So that's another approach to show that if your exponent is 0, your answer is 1. So we do have another law for this. So you can raise a quantity to an exponent of 0. When the exponent of a power is 0, then your value is 1. The only catch is that the base cannot equal 0. Cannot equal 0. So, for example, 5 to the 0th power is 1. A million to the power of 0 is going to equal 1. Doesn't matter what your value is as a base. If your exponent is 0, then that evaluates to 1. So, part B, we want to prove that 2 to the 0 is equal to 1. Again, we can use division to show that, oh, sorry, there's a negative 2. Negative 2 to the 0 is 1. We can choose any power of negative 2. So we've chosen 3. So negative 2 to the 3rd power is equal to negative 8. Divide it by negative 2 to the power of 3, or negative 8. Negative 8 divided by negative 8 is just 1. 8 divided by 8 is 1. Negative divided by negative is positive, so it's positive 1. So, using our laws, this has a common base, so we can subtract our exponents. Negative 2 to the 3 minus 3 is equal to negative 2 to the 0. This side was 1, so this must equal 1 as well. Alright, end of 3.2 is another show you know. Please give it a go.